Hello, my name is Mr. Asprey and this is Quadratic Simultaneous Equations, and if you're watching this in 2025 then check out my live revision session I've got planned for the Easter holidays. It's going to be smashing out loads of grade 9 questions, so if you're aiming for a grade 9 or you just want help on those really tough questions then check out that live session. Should be good stuff. Okay, the trick for this particular topic is you have one linear equation, which means there's no squared terms, and one quadratic equation, which means there are squared terms. Now, for the linear one, the blue one, we need to make one of the variables the subject. So we want it to be either x equals or y equals. In this case, it's done for us. We've got y equals. So what we do is in the quadratic one, we write the quadratic one out, but we replace the y with 2x minus 3. So I write out the quadratic equation. It starts x squared plus y squared, but I'm not going to write y squared because I'm going to swap the y out for 2x minus 3, and because it's y squared, I'm going to have to square that 2x minus 3, and that equals 2. And now we're good to go. We just need to expand out this double bracket. So I'll just write it like this, and then do each term. So I'll get x squared, and we'll do this times this, which is 4x squared. We'll do this times this, which is minus 6x. We'll do this times this, which is minus 6x. And we'll do this times this, which is plus 9. And that equals 2. We'll then collect up the like terms. We've got x squared. So that makes 5x squared. We've got over here, we've got a minus 6x and a minus 6x. So that makes minus 12x. And then I can minus 2 to both sides, which will make this plus 7 and then equal to 0. Because I want it to equal 0 because it's a quadratic, which we are going to solve using either the quadratic formula or factorization. So I'm going to factorize it. I'm going to call this term is a, and this term is c, and this term here is b. And we want to multiply the a and c term, which is 5 times 7, which makes 35, and we want to write the b term down as well, which is minus 12. So we're looking for two numbers that times to make 35 and add to make minus 12. They are minus 7 and minus 5. Now because the a term is 5, we write 5x in brackets, 5x, and then all divided by 5. And then we put these two numbers in here. So we have minus 7 and we have minus 5. And then all we need to do is divide this, these two brackets by 5. So just dividing one of them will be enough because these two things are times together. So just dividing one of them will work, and it will be the one on the right because that will give us x minus 1 because that's divisible by 5. So either 5x minus 7 equals 0, or x minus 1 equals 0. In this case, 5x will equal 7, so x will equal 7 over 5. And in this case, x will equal 1. Okay, so now we just need to go back to the start, and this equation here should tell us exactly what the corresponding y coordinate is. So you double the x and then you minus 3. So this one should be nice and easy. Double the x and minus 3. So that means you're going to get 2 times 1 minus 3, which is minus 1. And for this one, double the x, so 2 times 7 over 5, and then minus 3. That will give us, I should know this, minus 1/5 I'm going to go with. Just double check because I don't want to look like an idiot. Yes, minus 1/5, perfect. Okay, great. And then finally what I would do is I would just write them out again so they're next to each other. So we have this, and a separate solution is this. Perfect. Question 2 is the same deal as last time, relatively easy because we have it already as one of the variables as the subject in the linear equation. We've got y equals something bloody 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 x. So that means we can just stub straight into the quadratic one. So I write the quadratic one out, x squared plus, but then for y, we swap it out for 3 minus 2x. And because it's y squared, we have to square that. And that equals 18. We're then going to have to multiply out this double bracket, because it's a squared bracket, so it's times by itself. So this gives x squared plus, that's 9. That's minus 6x. That's minus another 6x. And that's plus 4x squared. And that equals 18. I can then collect up the x squareds, of which there are 5 of them. I can then collect up the x's, of which there are minus 12. And then I'm going to subtract 18 from both sides, which will leave me with 0, and it will be 9 minus this 18 is minus 9. And that's the quadratic we have to solve. So we've got the a and the c term. So we write up here ac is 5 times minus 9, which is minus 45. And the b term is minus 12. So we just write below it b is equal to minus 12. And then we have to find two numbers that times to make minus 45 and add to make minus 12. And those two numbers are minus 9 and minus 3. And that doesn't work. Okay, try that again. One of them needs to be negative, one must be positive because they times to make a negative. So it's minus 15 and 3. Yes, that works. So because the a term is 5, I write 5x, 5x, then all divided by 5. And then I just pop these two numbers in. So minus 15 and plus 3. And then we need to figure out which bracket can I divide by 5. Well, it's the one on the left. When I divide that through by 5, I get x minus 3. And this one I can keep exactly the same. And just dividing one bracket by 5 is enough to divide the whole thing by 5. Okay, so this tells me that x equals 3. This one, to solve it, would equal 0. So 5x would equal minus 3. So x would equal minus 3 over 5. Right, we've got the x values. We need to go back to the original linear equation, which we swapped out, and that's going to tell us our y values. So to find our y's, we're going to have to do 3 minus 2 times our x. So this one is 3 minus 2 times 3 is 6, so 3 minus 6 is minus 3. This one, we have to do 3 minus 2 times minus 3 over 5. And just to avoid embarrassing myself, I will do that on the calculator. So 2 times minus 3 over 5, and that is going to be 21 over 5. Sounds good to me. Let's just leave it like that, 21 over 5. And then I'm going to finish off by just pairing them up. So x equals 3 goes with y equals minus 3. And another solution, x equals minus 3 over 5 goes with y equals 21 over 5. So nice and paired up so the examiner knows that I know. The examiner knows that I know what I'm doing. Yeah, nice. Okay, question number 3 is a bit trickier because for the first time the linear one is not exactly with one of the variables as the subject. So we have to do a little bit of rearranging of the linear equation before we can sub it into the quadratic. But that's no problem. I mean, we could make y the subject, but then we'd be dividing by 6. Don't want to be doing that. So let's make x the subject, and we just add this 6y to the other side. So we get x is equal to 5 plus 6y, or 6y plus 5. Either way is fine. Okay, so now we've got one of them as the subject. We rewrite the quadratic one, but we just replace, anytime we see an x, we replace it with this 5 plus 6y. So straight off the bat, there's x, so we replace that with 5 plus 6y. and then that x is times by y, so times by y, and then we minus 2y squared, and that equals 6. Okay, we're going to expand this bracket out. We're going to get a 5y, and we're going to get a plus 6y squared minus 2y squared is equal to 6. So let's collect up the y squares first. 6y squared minus 2y squared is 4y squared. We've got plus 5y is equal to 6. And then we can minus that 6 from both sides to make it equal 0, as we always want. And then we do our quadratic factorizing. So we say a times c, so this is the a and this is the c, is 4 times minus 6, which is minus 24. And then the b term is the number of y's in this case, and that's equal to 5. So two numbers that times together to make minus 24 and add to make 5 are, they must be one negative, one positive, and the positive one must be bigger because they add to make a positive number, so it's 8 and minus 3. Okay, now because the a term here is 4, we write 4y, all divided by 4. And then we just chuck these numbers in here, so positive 8 and negative 3. We decide which bracket can we divide by 4. Where are we going to divide this 4? We're going to divide it all into this one here. So dividing that bracket by 4 gives me y plus 2. And then the 4y minus 3 stays the same, and that equals 0. Okay, so y equals minus 2. And over here, 4y equals 3. So y is equal to 3 over 4. Right, now we need to find the corresponding x coordinates. Now sometimes people make a mistake. If they've subbed in x and they've solved a quadratic, they're so used to solving quadratics in terms of x, they forget that actually these are the y values. But we need to find the x values, and what we do is we go back to the start to our rearranged linear, because that is going to tell us exactly what the x's are. So the x's are equal to 5 plus 6 times the y's. So this first one is 5 plus 6 times minus 2 is minus 12. 5 plus minus 12 is minus 7. And this one, see what I did there? I wrote y equals, because I'm so used to subbing back in for y, sometimes you've got to remember that you've got y, you need to find x now. So x equals 5 plus 6 times 3/4. 6 times 3/4 is 4.5. So 5 plus 4.5 is 9.5, or 19 over 2. We'll leave it like that. Okay, so now we write it all out nice and neatly in pairs. So x is minus 7, y is minus 2, and x is 19 over 2, y is 3 over 4. Perfect. Right, next question looks a bit tricky again, but we're going to always, as always, we're going to start with the linear, the one without the squared terms, and we're going to make one of the variables the subject. Now here I'm going to go with x because I don't want to be dividing, so x is the perfect one to go with. So what I need to do is move that to the other side, becomes positive, move that to the other side, becomes a negative, so it's 1 minus 2y. Okay, now we can write this one out. But every time we come up against an x, we need to sub in, that's horrible colouring, isn't it? Every time we come up against an x, we need to just replace it with this 1 minus 2y. So straight away, we've got an x squared, so that's 1 minus 2y squared. We then minus 9y. We then minus x, which is 1 minus 2y. And then that equals 2y squared minus 12. Okay, let's expand this bracket out. I'll write it as a double bracket. Here, we'll write this as, that's minus times 1 is minus 1, and minus times minus 2 is plus 2y. Okay, so because of the double negative there, I've got minus and a minus, that's going to make a plus, and then it's just 2y. Okay, so this needs to be expanded out as well. So we've got 1, we've got minus 2y, we've got minus 2y, and we've got plus, because 2 minuses, 4y squared. And then that equals 2y squared minus 12. Okay. Right, let's collect up all this stuff on the left hand side because there's a lot going on here. We've got 4y squared. Let's look at all the y's. We've got minus 2, minus 9, plus 2. So that is minus 11 when all added up. And then we've got a plus 1 and a minus 1, so that cancels out. And then we've got equals 2y squared minus 12. Okay, we need to make it all equal to 0. I'm going to move this over to that side by minusing 2y squared from both sides. I'm going to keep the minus 11y, and I'm going to move this over by adding 12 to both sides so that the right hand side is equal to 0. Great. Right, now it's time to factorise. I'll use my AC method again, where that's A and that's C. So that becomes 2 times 12, which is equal to 24. And the B term is equal to minus 11. Two numbers that times to make 24 and add to make minus 11 are minus 3 and minus 8. And because this A term here is 2, we're going to write 2y, all divided by 2. We stick in these two numbers, minus 3 and minus 8. We think which bracket can we divide the 2 into? Well, best one will be this one because it's both got factors of 2. And this gives me y minus 4 is equal to 0. This means that y is equal to positive 3 over 2, and this means that y is equal to 4. Now we go back up to the top, we check what's the x equation. So x is equal to 1 minus 2 times by the y. So x here is equal to 1 minus 3, which is minus 2. And then here, when y is 4, we've got 1 minus 2 times 4, which is 1 minus 8, which is minus 7. And then the final thing we do is we write out the answers nice and neatly as pairs. So x equals minus 2 goes with y equals 3 over 2. And x equals minus 7 goes with y equals 4. And that is job done. Okay, next one. And this one is quite nice because we've already got the linear written out for us in terms of y. So we can just replace it with all the y terms in here can get swapped out for 2x minus 3. So writing the quadratic one out again, we've got 3x squared plus y is going to get swapped out for 2x minus 3, but that's y squared, so we have to square the bracket. Minus x times by y, which is again going to get swapped out by 2x minus 3, and all that equals 5. Okay, spanning out this double bracket, I will get 4x squared. There will be a minus 6x, there will be a minus 6x, and there will be a plus 9. Expanding out this bracket, I'll get minus 2x squared, and I'll get positive 3x, and that equals 5. Okay, let's collect up all the x squareds. We've got 3, we've got 4, and we've got minus 2. So that makes 5x squared. Let's collect up all the x's. We've got minus 6 and plus 3. So that's minus 9. And then we've got plus 9, and that equals 5. So then let's bring it all over to one side. So let's take away 5 from both sides to get such. And then we need to factorize that. So I'll do the AC method where this is A and this is C. So that's 5 times 4 equals 20. And then the B term is the number of x's, which is minus 9. So we're looking for two numbers that times to make 20 and add to make minus 9. They are minus 5 and minus 4. Now because this term here is 5, we say 5x, all divided by 5, and then we plonk these numbers in. So minus 5 and plus 4. Steady, minus 4, those numbers. Now, which one can we divide by 5? It is the one on the left. This one can be divided perfectly by 5, and when we do, we get x minus 1, and over here we get 5x minus 4. Okay, so this means x equals 1, and this one means x equals 4 over 5. Yeah, that's correct. Okay, now we go back to the start and we sub in to work out our corresponding y's. So we times the x by 2 and then we minus 3. So that's minus 1. And over here we times the x by 2 and then we minus 3. Bit lazy. Minus 7 over 5, perfect. Okay, and then the final step, just to finish it off with a nice cherry on top and a nice round bow, write the equations, the solutions out as pairs, so the examiner knows that you know that they come as pairs, like such. Beautiful. Okay, here we go again. This one is the linear one. We want to make x or y the subject. It's easiest to make x the subject so we don't have to divide. So let's plus 2y to both sides to get 2y plus 3. Yes, perfect. We then write out the quadratic one, but we replace any x's with 2y plus 3. So straight away we've got an x squared, so we write 2y plus 3 squared. Minus y squared, and then we've got plus 2x, so we write 2y plus 3, and that's equal to 10. I'm going to multiply out this bracket. I'm going to do it in one step to save a bit of time for the video. So we get 2y times 2y is 4y squared. We'll get a 2y times a 3, and we'll get a 3 times a 2y. Both give 6y. There are 2 of them, so it's 12y. And then finally we get the 3 times the 3, which is 9. And then we're minusing y squared, and then we're plussing, expanding this bracket out to get 4y, and then plus 6. And that equals 10. We'll collect up the y squareds, and this gives us 3y squared. We'll collect up the y's, and we'll get 16y. And 9 plus 6 is 15, and that equals 10. We'll minus 10 from both sides so that it's equal to 0, like so. And then we do the AC method. So that's A and that's C, and this is going to help us factorize. Of course we have to do this because it does say show Keller algebraic working. You could use the quadratic formula, but all of these are going to factorize, so it's just much easier to use the factorization method. 3 times 5 is 15, and the B term is this term here, which is 16. So two numbers that times to make 15 and add to make 16 are 1 and 15. Now because this is free, we write 3y in each bracket, and then we divide it all by 3. We put these numbers in, so plus 1 and plus 15. Which bracket can we divide by the 3 by? It's this one over here, perfectly divided by 3. So we get y plus 5 in that bracket. So if this is equal to 0, then it means y must equal minus a third. And if this is equal to 0, it means y must equal minus 5. We then go back to the start where we rearranged for x, and that's going to help us find the corresponding x value. So the x value, you times the y value by 2, and then you plus 3. So this will give us 7 over 3. And for this one, we times the y value by 2, and then we plus 3. So minus 10 plus 3 is minus 7. And then the final thing we do is we just tie it up in a nice bow by writing the solutions out in pairs. So these two go together because, well, they do. Don't know how to explain it better than that, really. And these two go together. So that's x equals minus 7, and that's y equals minus 5. Perfect. Okay, next question. The line with this equation intersects the curve with this equation at the points A and B. Find the coordinates of A and B. Well, this is exactly what we've been doing, just a bit of context, but we just basically solved the simultaneous set of equations. So we need to make the linear one, x or y, the subject. Easiest thing to do here is make x the subject, so we don't need to divide. Let's minus 1 to both sides, gives me 2y minus 1. Next, we replace all the x's in this quadratic equation with the 2y minus 1. So we write it out, 3y squared plus 7y plus 16 is equal to x we replace with 2x minus 1, and because it's x squared, we square it. Minus x we replace with 2y minus 1. Okay, so we do 3y squared plus 7y plus 16. Always make sure you put it in brackets as well when you sub in to avoid any errors. Right, when I expand this out, I can do that over here nice and quickly. We're going to get 4y squared. We'll get minus 2y and another minus 2y, so minus 4y, and we'll get minus 1 times minus 1 is plus 1. Here, this is the biggest error people make. They're happy to say that's minus 2y, but they forget to apply the negative to the second term. That changes to a plus 1 because of the negative outside the bracket. Okay, now before I set it equal to 0, I'm going to want to tidy up both sides as much as possible. So let's collect up the y's here, of which we've got minus 6, and the numbers we've got just plus 2. Okay, now we decide which side to move them all over to. I'm going to pick the right side to keep the y squared positive. So minusing 3y squared to both sides gives us y squared on the right. Minusing 7y to both sides gives minus 13y. And then minusing 16 from both sides gives minus 14. And that equals 0 now. Perfect. This is the first one that we've done, which you can just factorise without having to do the AC method, which is quite nice. Two numbers that times together to make minus 14 add to make minus 13 must be minus 14 and plus 1. Yes. So y is equal to positive 14 to make that bracket 0, and y is equal to minus 1 to make that bracket 0. Okay, now we can go back here where the original linear equation was rearranged, and that tells me that the x coordinate is 2 times the y coordinate minus 1. So that is 28 minus 1 is 27. And here, this tells me that it is x is equal to 2 times the y coordinate minus 1. So x is equal to minus 2 minus 1, which is minus 3. Okay, it says find the coordinates of A and the coordinates of B. Now, it doesn't give us any reason why any of them will be either. Oh, okay, perfect. It doesn't tell us, we don't know which one's which, but it doesn't matter. So 27 for x is paired up with 14 for y, and minus 3 for x is paired up with minus 1 for y. Perfect. Okay, final question, and we've got straight lines. So we've got the linear one, and we've got the quadratic one, and where they intersect is the solution to the simultaneous equations. So that will give us points P and Q. And then it says find the coordinates of the midpoint of P and Q. So just an extra little step to make this the hardest question in a topic which is relatively routine. If you watch this whole video, then you'll know that I haven't done anything special, just done the same process over and over again. Okay, so the first thing we do is we make x or y from the linear equation the subject. Now I'm going to pick making x the subject because that way when I plus the y over, I get y plus 3, and it keeps everything positive, which is just easier to deal with. So x is the subject, so now when I write out the green equation, I just replace any x with a y plus 3 in bracket. So it's 3 lots of x, which is y plus 3 squared, minus y squared, and then plus x, which is y plus 3, times by y, and that equals 9. Okay, I'll just quickly over here do x plus 3 squared, sorry, y plus 3 squared, which is y plus 3 times by itself, which is y squared plus 3y plus 3y plus 9, which is y squared plus 6y plus 9. So if I'm timesing that by 3, then I need to just times this by 3. Now some people might make the mistake by timesing 3 into the bracket before squaring. We can't do that because BidMath tells us we must square first, which I've done over here, and then I'm going to times by 3. So I'm basically timesing this yellow thing by 3. So that's 3y squared plus 18y plus 27. And then we're over to this term, which is just minus y squared. And then we're over to this bracket, which is y squared, and then plus 3y. And that equals 9. Okay, let's collect up now the y squareds. We've got 3 minus 1 plus 1, so that makes 3. We'll then collect up the y's. We've got 18 plus 3 is 21. And then we'll collect up the, well, we don't need to collect them up because there's just 27 on this side and there's 9 on that side. Now we want to make it equal to 0, so we're going to subtract 9 from both sides, which gives us plus 18. This quadratic can be divided through by 3 because it's equal to 0. We can divide both sides by 3 and we'll get y squared plus 7y plus 6 equals 0. Okay, this can be factorised. Two numbers that times to make 6 and add to make 7 are 1 and 6. Therefore, to make this bracket 0, y must equal minus 1, and to make this bracket 0, y must equal minus 6. Perfect. Now we go back to the start to find our simplified linear equation, where one of them was the subject. And this tells me that x is equal to y plus 3. So let me just write them up here. And let's go that x is equal to y plus 3. So that's 2. And x is equal to y plus 3. So that is, what's that? Minus 3. Okay, great. So the two coordinates then are 2 minus 1, because these two pair up, and minus 3 paired up with minus 6. And we've been asked to find the midpoint of these. So the midpoint is equal to the two x coordinates added together, divided by 2, and the two y coordinates added together and divided by 2. It's the average of the x and it's the average of the y. So we'll take the two x coordinates, so that's 2 and minus 3, and we divide that by 2. And we'll take the two y coordinates, which is minus 1 and minus 6, and divide that by 2. This gives us minus 1 on top over 2, so just minus 1 over 2. And this gives us minus 7 on top, divided by 2, so minus 7 over 2. So there we go, and that is job done. Hope you enjoyed that. See you in the next one. Bye for now.